Hello, my fellow YouTubers. This is Roy back again. Let's do an experiment. Right here, I got a 1/2-inch steel rod. It's 36 inches long. I got a mark here in the middle. And I have my good hammer. So we're going to grab this from the top. I'm going to grab it with 2 fingers. And we're going to strike the top. Now, did you hear that? Let's go ahead and go down about 2 inches. And let's do it again. Did you hear that? Now let's go ahead and go down a little further. We're about 4 inches from the top. We're going to strike it. You can hear the difference in tones, right? Now we're down about 6 inches, 7 inches. Now we're about 1 foot. So, you can see as we consider this shunting with 2 fingers, and we work our way down the rod, you can hear different tones, okay? Now, how do we go about getting a resonant part of this pipe? Where do we know where to hold it? Well, that's why we got that center mark, that center tap, we're gonna call it. Let's go ahead and pinch it at the center tap. Let's strike it and listen to it. That was beautiful. Beautiful harmonics there. Let's go ahead and grab it again and smack it. So, let's talk about this. 1/2-inch pipe. You grab it in the middle. So you're tapping it in the middle. You are striking the end of the steel with a hammer. You're putting the force in through the steel. So it's going all the way down to the end and bouncing back. And then my finger is in the middle. So, good question for you guys today. What is going on here? Why does tapping the center? Now, if I go below the center, what do we hear? Not so good. If we go above the center a little bit, not so good. If we go back to the center, you can feel that continue ring, 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 ring. And that is the vibration going on here in equilibrium. Now, what are you saying to yourself? What is going on here? What is he talking about? What's that have to do with edge wheel or edge PMH or electricity? Well, it has a lot to do with it, guys. It has a lot to do with resonant frequencies and harmonics. Right here I have hanging the same stock, iron stock, 1.5-inch square iron stock, 2-spec per edge magnetic current book. Let's check for its harmonic. So I have it hanging in the middle, and before I had it hanging in the middle, I was grabbing it from the middle and I was whacking it from hand underneath and whacking it on top, and it had a good balance. And when I whacked it from the side, it just went on forever. So we're gonna go ahead and get you guys a little closer. Let's go ahead and see what we hear, okay? You ready? Let's see what we hear. Still going. Still vibrating. Let's do one more experiment. I'm going to take a tuning fork and we're going to whack it, and we're going to then stop it and see if the tuning fork picks up the vibration. Nothing. Let's whack it together. They're both still going. Wow, let's do that again. I'm hearing a double harmonics. This is lower. This is higher. Still going. Still ringing. That vibration's still going. Still going, guys. Imagine that to be a pendulum. A penduli, we'll call it. Imagine that to be something that you could, those principles that we see here on the, I would say shunting has a lot to do with the return path of the strike. So when you're striking something, now this is be a special attribute here, because this here is bent over on itself. So it's creating this vibratorial airspace in between the mass, and then you got the length of the bar. On this here, you got pretty much the same thing, except for it's now linear. This is becomes a linear wave when you strike this. And this one here is not a linear wave. This is obviously a different way to trap in vibration into matter. So if you're curious why Ed Lee Scallon and I are talking about iron and vibrations and oscillations, as well as cymatics in the sense of harmonics, there's a lot of good tests out there you can do to show yourself that they're so related to electrical circuits. And that the electric circuit that you create, say if you were to take a coil such as this one here, and you were to create an environment for this coil based on what you were doing with it, and you wanted to oscillate. Now you can do a couple different things, various forms of oscillation, and you got your tank circuit, you got your wire path. But understanding the wire path is important too, because you could take your length of wire and you can center tap it, and you can make the center tap the strike point, or you can center tap it and go in on one end, drive it in drive the energy in there, have a center tap that would create, probably you could tap it right here and probably hook it up to one side of this to one plate of a capacitor, and the other side of this to the other plate of a capacitor. And I would think that center tapping of this wire, as long as this end of wire here has a return path, should create a oscillating system in that capacitor. You guys leave your comments. Peace out.